Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to be looking at the night sky for the night of the 25th, Christmas Eve, those nights. We will be looking at the sky for those nights, but we are going to be looking for something in particular. And we will mostly be looking in the morning and evening, at dawn and dusk, just after and just before sunset and sunrise. This is the best time to go looking for satellites. We've covered stars and planets and deep sky objects, and of course there's plenty more to say on those topics, but satellites are up there as well. They may be man-made, they may be artificial, but they are targets that you can observe. And as you might be able to tell here, on the evening of the 22nd, just about 5:30, these are objects you can observe with your eyes. Satellites are visible to the naked eye, even under city conditions, which is what is being simulated here. This is definitely a view in the city with all of the light pollution that entails, and you can add to that the moon, which is quite close to full on this date, but we can see a satellite, and this is real time. This isn't what the sky looks like right now for me, but this is running through time 1 second per second without speeding it up. And you might be able to see the satellite is moving pretty fast. They are quite fast objects. So when we go speeding through time in Stellarium, zooming forward to look at different times of the night, that can make the satellites really blur across the sky. But in real life, at real speed, they are moving quickly, but they're certainly in the sky still for a few minutes at a time, depending on where they cross the sky and exactly the path that they're taking. So this satellite, it must be pretty low. It looks like it's moving pretty fast, and it is moving almost as we'd expect. It looks like it's going from the southeast towards the northwest, so traveling across the equator as it orbits the Earth. It's not exactly orbiting the equator, but it's cutting across the Earth at a little bit of an angle, and that's pretty typical as well. We're seeing this satellite because of light that it's reflecting. Light from the sunset is hitting this satellite, and that's the reason that we're able to see it. Satellites don't produce much light of their own. Some satellites do have external light sources, some do have LEDs, but generally none of those are going to be bright enough for us to see with our naked eye. Instead, when we see satellites crossing the night sky, they're hitting, or light from the sun is hitting them, and particularly their solar panels, which can be quite bright, or quite reflective, and that causes them to be quite bright. So when a satellite passes across our sky at a different time of the night, so it is looking a little bit low there, but if I were to remove the ground and remove those buildings that are in the way, you'd see that there's no actual visible dot, and that's because the satellite there isn't in a position to be reflecting light from the sun back to us. So sometimes satellites are pretty much invisible unless you catch them blocking out a star as they cross the sky. You won't really be able to see them. It's only when they reflect light from the sun that they're visible, and the bigger the satellite, the bigger its solar panels, the more light it will reflect, and the lower it is in the sky, well, the closer it is to us. So the lower its orbit around the Earth, the closer it will be. That does usually mean they move faster. Satellites in low Earth orbit are usually orbiting the Earth pretty quickly, while those that are a little further out, they're moving across our sky a lot more slowly, or in some cases not really moving across the sky at all. So a geostationary satellite is a satellite that doesn't even appear to move. It seems to hang above a particular portion of the Earth. They're usually a good bit further out, so that can make them more difficult to observe. You might notice that I'm chasing a particularly bright, fast object here. The International Space Station. It is a satellite. It is a man-made satellite, an artificial thing orbiting the Earth with big, gigantic solar panels. It's pretty much the biggest thing we have up there, orbiting on a regular basis. So we have this very bright object really zipping across the sky. So this is 1 second per second, pretty much real time, and you can see it's noticeably drifting. Now, the International Space Station and all artificial satellites, they are under human control. We can move them in space. We can change how high they're orbiting and exactly what tilt their orbit is at. So that means predicting where the ISS is going to be. It's significantly harder and less reliable than predicting the planets. Nobody's going to decide that the planets need to be shifted a little bit up or down in the sky. whereas that can happen with the International Space Station. To observe certain things on the Earth or to see them in a different angle, sometimes the International Space has to move. So the further into the future we try to predict its motions, well, the less likely they are to be accurate, and eventually predicting a few months into the future, there really isn't any point. We're only predicting a few days into the future here, about a week, so the chances of the path being changed dramatically are less, but the path could still be changed. So I'm showing you where these are, where this particular satellite is going to be in the near future. If you'd like to see it further out in the future, you might need to recheck exactly where it's going to be. So the International Space Station crossed the night sky there at around 5 o'clock in the morning and again at around 7 o'clock in the morning. But we can see crossing here close to 7 o'clock in the morning, really, really close to sunrise. In fact, sunrise has already begun. The dawn is beginning to break. We can see that the International Space Station is cutting across the whole sky, and it's moving reasonably quickly. Now, that's all we're getting to see in a city. With this amount of light pollution, a lot of the smaller satellites are going to be very difficult to see. But if there was less light pollution, and hopefully this will show up, then there'd be a lot more stars, and you'd also get to see more satellites. Even the faint little very small satellites that are traveling very quickly, they'd be more noticeable in a darker sky. So I'm not seeing a load of them here. There's one down there just drifting across the sky. I'm sure you can see that's moving relative to the stars. It can be hard to catch when there's so many stars in the sky as well, and there is a little bit of a glow of sunlight blocking out some of the fainter objects. The ISS is, of course, nice and clear. There's a few satellites down there just above the sunrise. Satellites, depending on where they are and the angle their solar panels are at, they'll reflect more or different amounts. Some of them still won't be very visible, even close to dawn. The International Space Station, because it orbits the Earth so quickly, here we get to see a few more satellites now moving backwards. Because the International Space Station orbits the Earth so quickly in low Earth orbit, you can absolutely see it twice in one night, twice in the space of just a couple of hours in this case. So if you go out at about 5 o'clock in the morning, you'll be able to see the International Space Station zipping across the sky very briefly, just a minute or two. If you go back out then closer to 7 o'clock, you'll be able to see the International Space Station for much, much longer. So there it is, the International Space Station in our shadow and moving into the position where it'll catch the sun's light and reflect it back to us. So sometimes when the International Space Station is crossing the sky, you only see it for a couple of seconds, and it might appear to disappear. It'll be there and then it'll vanish in the middle of the sky. It's just moving into our shadow. You don't have to be worried. And you can see it orbiting the Earth multiple times in the space of just a couple of hours. The ISS is really, really fast. So moving forward here to the morning of the 25th, I'm sure a lot of you will be up nice and early in the morning on the 25th. It's hard to stay asleep if you've got presents coming the next day. So the International Space Station will be there. This is a bit closer to 6 o'clock that we're going to see it. I think, 10 to 6 or so. There's the International Space Station drifting across the sky for just a couple of minutes, so you might miss it, looking roughly over into the east. So you'll see that bright light of Venus. It will be the morning star for Christmas morning. And because we're looking at a dark sky here, we're seeing loads of satellites. You can see them zipping across the sky in various different orbits, moving in loads of different directions. Because we control where satellites go, because we launch them on certain paths, and because some of them have rockets or ways of interacting with the Earth's magnetic field that allow them to change direction, you can have them zipping all over the place. They're not going to follow the kind of regular paths that we see with the planets, and it's a lot more erratic. It's a bit more like asteroids, but they will stay in the sky for a little bit longer. Most of them aren't crashing through the Earth's atmosphere. Of course, some do. When satellites are getting retired, when they're getting decommissioned, burning them up in the Earth's atmosphere is often one of the best ways to do it. Now, that is a very bright object zipping across the sky. It's not the ISS, but it is something nice and big. So there are a few big low-Earth satellites. You might also see pieces of rocket engines or rocket stages that have broken off, drifting across the sky. Those can be very big and very bright. But we are coming up here now a bit after 7 o'clock in the morning to the time when we should start to see the ISS zipping across the sky again. There it is on the 25th, really nice and bright, really, really prominent, just above the sunrise, and then disappearing over in that eastern direction. And that's going to happen for a couple of days in a row, or it appears likely that this is going to happen for a couple of days in a row, skipping every second day. you should be able to see it at about 5 o'clock in the morning, and then again at about 7 or 8 o'clock in the morning as we move through this portion of the year. So it is pretty much the biggest satellite, and it's one of the most impressive to see really zipping across the sky. If you have binoculars or a telescope, it's well worth a closer look, but I would recommend taking that closer look closer to the middle of the night, around 5 o'clock rather than around 7 o'clock. But there it is, it's going to be there. So if you're up early on the 25th, or if you've recently opened your first telescope on the 27th, as long as no major changes are made to the ISS's path, you're going to be able to see that over the next couple of days. And I hope you do. I hope you do get a chance to see it. It is visible in the city and in the countryside. And of course, we're coming up to the end of the year, so very soon we'll be looking forward into January and into next year. So if you enjoyed this video, I hope you'll like it and come back for the next one. You'll be more likely to get reminded of my videos if you subscribe to the YouTube channel. So if you enjoyed the video, please do. And hopefully I'll see you next time.